Hi guys, this is Rui Raptor with step 14 and last one of how to assemble the TEVO Black Widow. Today we will check the E-steps. The steps per millimeter are affected by the size of the pulleys to move the X and Y axis, threaded rod to move the Z axis, and the method of extrusion. These steps are defined in firmware and can be added through the display menus or using G-codes commands. Checking the steps is the way we guarantee that our machine is working correctly and that the axes are moving the correct distance. And the best way to check this is to make the machine move a specific distance and measure if that axis really moved that exact distance. The travel distance must be the same as the distance you told the machine to move. I have explained how to check this for the Tarantula, but I will explain again for the Black Widow. The steps can be calculated by math. You take the gears into account and the result is the number of steps. If you enter the Bruiser Calculator website, you can easily check this. In theory, these values should be spot on, or extremely close. If they are not, you might have issues with your hardware. Some of these issues could be the frame not being squared, the belts not tight enough, the pulleys not tightened or out of spec, etc. etc. If you notice a big difference between the travel distance and the desired distance, then you need to check what's wrong with your hardware first. But if you notice just a small difference and at the same time you check your hardware and you can't find anything wrong, then it's okay to adjust the steps so that your printer gets perfectly accurate. In the same Bruiser Calculator website, there's a remark that has the same statement. The wrong method, and that you should never ever do, is to print a cube, measure it, and if the cube does not have the desired measurements, change the steps to compensate. This is absolutely wrong. So, having said that, let's start with the X-axis first. Get a thin and sharp needle and a precision ruler. Take a little bit of painter's tape and secure the needle under the fan, for example. I designed these small ruler stands. They keep the ruler at 45 and 90 degrees, which will help getting a much better reading. You can find a link for them in the video description. Or just place the ruler on top of the heat bed and secure it with painter's tape. In both cases, make sure that the ruler is parallel with the axis you are checking. Adjust the ruler or the axis so that the needle is exactly at the 0 mark. Move the axis 100 millimeters and check the reading. If you need more accuracy, increase the travel distance. In my case, I found that the X and Y axis were not 100% accurate, so I moved 150 millimeters instead for a better reading. And I can tell that the axis moved more or less 149.6 or 0.7 millimeters, so I will round it up to 149.65 millimeters. Go back to 0 and confirm that it returns to the initial mark. Now, the formula for adjusting the steps is just a simple rule of 3. You take the steps used in this trial, stock value is 160, and the distance that it actually moved with those steps, the distance that you were aiming to, and finally the new step you are trying to calculate. You multiply the current steps with the desired distance and divide that by the moved distance. And this is the new step value you need to type in. Repeat the process as many times as you need until you get a stable result. Do the same procedure for the y-axis and the z-axis, and don't forget to store the new values into the EEPROM. The extruder, however, is not as easy. You might need to do this more often. While for the X, Y, and Z you just need to do this once and check from time to time, for example in your yearly maintenance. For the extruder, you might need to do this, for example, when changing to different filament types. So for this, you need to heat up the nozzle to the same temperature you will use with your filament. First time you heat up the nozzle, check if the nozzle is correctly tightened. Next, load the filament. I'm going to use my spool holder to secure the ruler. You can find a link of it in the video description also. You will move 100 millimeters, but mark the filament 20 millimeters above, so that if it overshoots the distance, you can measure it. Extrude 100 millimeters of filament. Do it slowly, but continuously. When done, check how much filament moved using the Sharpie marks you made at the beginning. Adjust the steps using the same formula used before. Next, when When you print your favorite calibration cube, adjust your flow percentage in your slicer if the measurements end up different. And this concludes the assembly video series. The printer is now ready for the first print. I hope you enjoyed the series, and I'll see you next time.